Okay, another little video on some facts about Laplace transform. First, I want to talk about linearity, and we can talk about this pretty quickly. This is linearity in the sense of sort of linear algebra, a linear transform. Basically, that the Laplace transform respects addition and multiplication by constants. Here's what I mean by that. If you take the Laplace transform of two different functions, or they could be the same, of course, add it together or subtract it, it's the same as if you took the Laplace transform of each one separately and then added or subtracted those. That's the first one. And secondly, constant multiplication. So if we take any function and multiply it by a number, alpha, and take the Laplace transform of that, it's the same as if we just took the Laplace transform of the function and then multiplied by the constant afterward. Okay, both of these are, I think, believable. And what it allows us to do, for example, is, let's say we have a function like four plus 3t minus t squared, and we want the corresponding Laplace transform. So what we're able to do is just take the Laplace transform of each piece. That's using rule 1. Now, to figure out the Laplace transform of 4, we can think of that as, of course, 4 times 1. And we know the Laplace transform of 1. It's 1 over s. And so this will just be 4 times 1 over s, using the second rule. So 4 over s. Plus, now 3 times t. The Laplace transform for t is 1 over s squared, and so times 3, 3 over s squared. Minus, and then finally t squared, its Laplace transform is 2 over s cubed, and we don't have a constant multiple in front of that. So that's the idea, is that you can do things like that. Just to do another quick one, let's say we have 3e to the 2t minus 4e to the negative t. And we would like the Laplace transform of that function. All right, so yeah, just using both rules, it's going to be 3 times the Laplace transform of e to the 2t, which will be 1 over s minus 2. So of course I could write that as 3 over s minus 2. And then minus 4 e to the minus t. So the e to the minus t, its Laplace transform is 1 over s plus 1, and then times 4. Okay. So that would be the answer. So this is how linearity works. Now be careful. Maybe as you would expect, we don't have a similar thing for the product or the quotient of two functions. It's not the case that the Laplace transform is just the product or the quotient of the two individual ones. So you would expect that, right? Because a Laplace transform stems from an integral, and of course integrals don't have any kind of product or quotient rules. They had these kinds of rules, integrals did, but they did not have product or quotient rules. It's incredibly easy to see why this is true. I'll just show you the first one, and the second one is kind of the same thing. The Laplace transform of y1 plus y2. Well, that would be the integral of y1 plus y2 times e to the minus st dt. I guess I should put parentheses t on these guys. Right, but we can just distribute this. We get y1 of t e to the minus st, and then plus y2 of t e to the minus st. And yeah, now basically we're just going to rely on the linearity of the integral, which we know from calculus. The integral of two things, we can break that up, as you see. And the first integral is just the Laplace transform of y1, and the second one is the Laplace transform of y2. As I say, that's the first linearity rule, the second linearity rule, is the same idea.